All right, welcome back. So today we are doing a question called searching a matrix. So here's the question. Given a matrix that is organized such that the numbers will always be sorted left to right, and the first number of each row will always be greater than the last element of the last row. Search for a specific value in the matrix and return whether it exists. Here's an example. Okay, so here we have an example. As you can see, the matrix is actually formed in a pretty simple way. It always goes up 1, 3, 5, 8. It's always increasing, and then also the first element is always bigger than the last element on the previous row. So then 10, 11, 15, 16, 24, 27, 30, 31. So that's pretty nice. It's literally just sorted. It's just a sorted matrix, extremely sorted. So let's go to the drawing board and think about how we can do this. So here we have our matrix. So the key to this question, how to find if the value is in it, the brute force way, obviously, you can just search through the whole matrix and just do one by one, and then you can see if it's there or not, and that would take O of n operation. And the reason, or actually, if its row is m and column is n, then it would take m times n, but that would be too long because you could do it somewhere better. And the reason why you could do it better is because it's sorted. So how can you take advantage of this sorted matrix? Well, the key to this is that you can look at it as a huge array, right? If you look at it as a huge array, then it's essentially just an array question masked with the matrix. So if you look at this, it would give you 1, 3, 5, 8, 10, 11, 15, 16, 24, 27, 30, and 31. So that's essentially the array that represents the matrix. And if I gave you this array and I asked you to say, is this element, like for example, 15 inside this array, then how would you do it? Then you'd probably say, yeah, I'll just do a binary search because it's sorted. And that's exactly what you have to do with this question. You just have to do a binary search, but on the matrix instead of the array. The only hard part, or the tricky part, is to know how to do a binary search on the matrix. So just do a normal binary search, but you're going to be using some characteristics like the row length and the column length to find the element that you're supposed to get to. Instead of using an array, you map the array number to a row and column. So let's take an example. Let's take 15. And then what's the array index? 0, 1, 2, 3, 4, 5, 6. It's 6. So how can you map 6 into a row and column? So the key here is to use the row length and the column length. So what is the row and what is the column? And we'll try to reverse engineer this. So the row, which row is it? 0, 1, the row is 1. Which column is it? 0, 1, 2, column's 2. So what kind of operation can you do on 6 to get 1 and 2? So the key here is to divide this array index by the column length to get the row, right? And the reason why is because, so you want to know which row is it. Is it this one, the 0th row, the first row, or the second row? Then what you want to do is you just want to divide by 4 because the column length is 4, and then it will tell you in which row it is. So this is essentially 6 divided by 4, which is the column length, right? This guy. And then to get the column number, how do you get that? Well, you know that it's there's 4 elements here. So what you want to do is you want to get this element, and now 2. So then how do you get this is you do 6 and then you mod it by 4. And then when you mod it by 4, it gets 2. And then which is this? 0, 1, 2. So then that's pretty much how you get, you map from the array index to row and column. So then what you do is you just do a normal binary search, but each time you want to select a number, you want to select your middle. What you want to do is you want to just map the index into a row and column. And then that's what you do. All right, so let's do the code for this. Actually, before we go to the code, let's talk about the time complexity. So the time complexity would be log of mn. The reason why is because m times n equals the number of elements in the array, the long array. And then usually when you do binary search, it's logarithmic time. So that's it. Yeah, m meaning column and then n meaning row. So then that's it. And then in terms of space complexity, because we don't add anything, then it's constant. So O of 1. Oops, O. Yep. All right, let's do the code for this. All right, search matrix. So first what you want to do is check the length. This is the base case. If the length is equals to 0, it means there's nothing in it anyway, so we're gonna return false no matter what. Now we want the row length, and that would be the length of the matrix, and then column length would be the length of one of the rows. So we'll just take the first one. Oops. All right, so now we start doing the binary search. So for low, we're gonna initialize it to 0, and then for the high, we're gonna initialize it to the length of the array that would have been. So which is m times n, which is row length times column length. And now what we do, we just do a simple binary search, and you should know how to do this like on top of your head. So you get the mid first, which is low plus high divided by 2. And then now what you want to do is you want to access it, right? So that's a little bit different. So you access it by doing kind of like the array, but instead you're going to get the row and column by doing mid divided by column length. Okay. And then you also do the mod column length equals value. If it is equal value, then you return true. That's good. And then the other case is if it's smaller than your value. If it's smaller than a value, then you want to go to the left, right? And how do you do that? You make low equals to mid plus 1, and then else high becomes mid. And then if you still can't find it once you've completed this binary search, you return false. So let's see if it works. We run it. Excellent. So for this, it's supposed to turn false, and then this is true, and then that's it. So let's try a few more. Let's search for 30. It should give us true. Excellent. Yep, so that's pretty much it. That's how you do it. And yeah, I hope you learned a lot. Thank you so much for watching. See you in the next one.